All right, for this one, this video, we're going to take a look at the cumulative study guide, numbers 16 through 22. So we're looking at number 16 first. So I've changed the directions to solve, as that is usually the direction that we have for equations. I've drawn my line separating my two sides of the equation to help us with balancing our inverse operations. And then I've also written out our acronym DCMI that I like to use for multi-step equations. So the D is standing for distribute on one side of the equation. In this case, we don't have any of that. Combining like terms on one side, p and 2 are not like terms, nor is 5p and -4, those aren't like terms. So we actually can check both these off. We do not have to do that in this equation. The M stands for move all your variables to one side. So right now we have a 5p on this side and a 1p on this side. So we do have to move them to one side. So we can either subtract 5p to get this off this side, or we can subtract 1p. Usually it's better to stick with the smaller one that we get rid of first, and it helps us to avoid negative variables. So this would go away, and we're left with 4p minus 4 equals 2. So we moved all our variables to one side, so we can now just use all our inverse operations to isolate our variable p. So the first thing we're going to do is we're going to add 4 as 4p, use that best friend analogy. 4 and p are best friends. The -4 is going to leave the party first, and we do that by adding 4 to both sides. So 4p equals, right here, that's 6. Then we're going to divide by 4. Right now we have p is equal to 6 over 4. As a fraction is the same thing as division. So 6/4, we could take this over here and do long division, or we can actually just simplify it. So 6/4, I'm going to divide both by 2, and we end up getting 3/2. So this is an acceptable final answer. Other answers could be 1 and 1/2 if you want it as a mixed number, or if you do long division or write it as a decimal, it would be 1.5. Okay, so these are all acceptable answers as well. For number 17, we again have an equation that we want to solve. So I'm going to draw my line. If I refer back to this DCMI, there's no distributing to do as there's no parentheses. Combining like terms, I'm looking in here. I don't have anything alike here, and this is alone down here. So we have to, and actually we have all our variables in one spot. So all three of these steps are actually already checked off. It's time to use inverse operations. So when I look at this, we can use the best friend model to figure out the -3 is best friends with the r, so that's going to stick around the longest. Okay. After that, -6 is on the same side of the fraction as it, so that's even like a next closest friend. We want to go ahead and get rid of this 6 first. Okay, so right now this is dividing by 6, so we are going to multiply by 6. We can think of it as 6 over 1, and we're going to do the same thing over here. Okay, this can cross cancel, which makes it go away, which is the whole point of what we're looking to do. So we're going to bring this whole entire thing down. Okay, -3r minus 6 is equal to 30. Okay, so this should look pretty comfortable to be able to solve this. So just like before, we're going to go ahead and add 6 first before we divide by -3. So add 6 to both sides. Bring this down. -3r is equal to 36. And then we'll divide by, now here we're going to divide by -3. I'll move this up. We're going to divide by -3 here because -3 divided by -3 is 1. And what we're looking for is 1r, okay? So make sure that when you're dividing, it has to be the same exact sign. Same thing with multiplying, it has to be the same sign. So divide by -3. So all that's left here is an r, and that is going to equal a total of -12. Okay, and there is our final answer. Okay, a lot of equations here, so I'm not going to cross out, I will leave it as evaluate. Okay, so once again, I'm going to write DCMI here. It's going to be a little bit more important in this one. So D, remember, stands for distribute. So since we have parentheses here, this number right on the outside mean to multiply. So we're going to go ahead and we're going to distribute and multiply it into each individual term. Okay, so we have 7 times 2p, which equals 14p. And then we're going to do 7 times, we're getting blurry, there we go. And then 7 times a positive 1, which equals 7, which because it's positive 7, we're going to get plus 7. Okay, from there, we already have 14p plus 7. And you know what? When you look at this, you might realize that it's the same thing on both sides. This is an identity problem, and you'll realize that because it's the same thing on both sides, anything will work. I do say that we want to go one step further and move our variables to one side before we make any claims. So I'm going to go ahead and subtract 14p from both sides, which would cause both of these to go away. 14p minus 14p is equal to 0. We just cross that out, and the only thing left is 7 is equal to 7. Okay, so once a variable is eliminated and there's nothing left, all we have is a statement. And we'll either have a true statement like this one, or we'll have a false statement like, say, 7 equals 10. So in those situations, we have a special type of answer. And what we're saying is that in this one, since it's true, the answer is going to be all real numbers. Another acceptable thing to say would be all solutions. And the symbol for that is like this. Okay, so this is your answer. What we're saying here, remember, is that any number that we plug in here for p is going to make this a true statement. So let's just try real quick. Let's try plugging in 2. Let's try that. So if I plugged it in, I'm going to rewrite everything, but instead of the p, I'm going to write a 2. Plus 1 is equal to 14 times 2 plus 7. All right, here we go. So 2 times 2 is 4, plus 1 is 5. 14 times 2 is 28. We'll write that one down at the same time. 28 plus 7 is 35, and 7 times 5 is 35 as well. So we can see, and this is just one example, but 2 works, but you'll see that anything you plug in is really going to work, and that's really evident when we look at this step where 14p plus 7 equals 14p plus 7. It's the same thing on both sides. All right, next here it says to simplify. Really, we're just multiplying two decimals. So the first thing I look at is it's a negative times a positive. Before I even go any further, I'm going to write a negative for my answer, and in my calculation, I'm going to ignore the negative sign because we've already made our decision on that. So I'm going to write 2.35 at the top. The one that has more digits is usually good to put on the top. And then 0.03 on the bottom. We're multiplying. So 3 times 5, 15. 1, that's 9. Plus 1 is 10. But again, 3 times 2 is 6, plus 1 is 7. And we don't have to, like we could do 0 times all of these, we're just going to get 0. So we really don't have to do that again. So to figure out how many times we have to scoop our decimal, we have 1, 2 here. We have 3, 4 total. So that's 1, 2, 3. And because we're doing a fourth one, we have to include another 0 here. So our answer is, I'm going to get rid of this negative sign, make sure I have enough room. It's negative 0. Put an extra 0 here. 0.075, messed that up. 705. Okay, so this is our answer here. I will accept it without this 0 in the front. That's fine. Okay, Peter bought 5 pounds for number 20. Peter bought 5 pounds of blackberries for $2.50. Ernest paid $4.30 for his purchase of blackberries. If they paid the same price per pound, how many pounds of blackberries did Ernest buy? So when I'm looking at this, I instantly see, because it says same price per pound, I know that this is a proportional relationship. So let's go ahead and set up for Peter. So I'm going to set a proportion. Peter had paid $2.50 for 5 pounds. I'm going to include my units in here. And on the other side, Ernest paid $4.30, and we don't know how many pounds that he'd gotten. And we could just check how many pounds of blackberries are. Okay, so that matches up with what we were leaving as X. So we have this problem to do. When I look at it, we're going to go ahead and just do our multiplication, our cross products. So right here, we have 5 times 430. I'm just going to write 4.3. And it's equal to 2.5x. Again, I dropped these zeros because they're not so relevant at the end of your fraction, or your decimal. Okay, so we'll do this multiplication. And then we have 1 scoop, so 21.5 is equal to 2.5x. So now we have some division to do. So x is going to be equal to whatever this is. So we'll bring this to the side. We have, I'm going to go right now, and I'm actually going to multiply both of these by 10 because I know in a second I'm going to have to divide and change this number to be a whole number. So I'll do it right now. So I'm going to divide 215 by 25. So 25 goes into, it doesn't go into 21, so actually we're going to have to go into 200. So I know that it goes into 100 4 times, and 200, that must mean it goes in 8 times. So 8, and that goes to 200. There's 15 left over at my decimal point. And I know it goes into 100 4 times, 2 more times would make 50, so that makes a total of 6 times. So our answer here is 8.6, but because we're talking about money, I'm going to go ahead and add that extra 0 again, which makes $8.60 that he had spent on how many, oh, I'm sorry, I actually messed that up. That's why you always have to remember to look back at your proportion and include your labels. So that is not supposed to be money. According to this, it says, or what we had left blank, it was, X was supposed to be pounds, right? Pounds of blackberries that he had gotten for $4.30. So really, this is 4.6 pounds of blackberries. So that's a lesson to always look back to make sure your label is correct by looking at the proportion, if you include labels, or maybe at least back at the question. All right, so looking at this equation, and again, it is an equation. It looks a little more complicated than it is. On the bottom here, there's just kind of something that we can kind of combine. So this is kind of like combining like terms. I'm going to bring this to the side actually. So -2 minus a -9. So I know that you can do keep, change, opposite, or when there's two negative signs right next to each other, you could do boom, boom. I'm going to go boom, boom. And that is a -2 plus 9. All right, so we have negative plus a positive, means we're really going to subtract, gets a 7, and the positive has a higher absolute value than the negative, so therefore the answer is 7. So this is now becoming C over 7 is equal to 25. Okay, so our inverse operation, since it's C divided by 7, we are going to multiply by 7. Remember, that's like 7 over 1, so we cross cancel, and do the same on the right. So C is going to be equal to 7 times 25. We know that 825s just from a problem ago is 200, so really we just take it one away and make it 75. We'll do the actual multiplication. 14, 17, 175. And there we go. All right, we have our last problem for this section. This is a matter of just simplifying. There's no equal signs here, so this is just one big expression that we have to apply PEMDAS to. So we have PE, multiplication and division. We're doing left to right if they're in the same step. And then we have addition and subtraction, which we do the same for. So looking here, first thing says to do parentheses first. So I'm going to look inside the parentheses, and then I'm going to start PEMDAS over again. Okay. So within the parentheses, I'm looking, okay, I see some multiplication, I see some division, and I see some subtraction. Okay, so when I see multiplication and division in the same step, I'm going to work left to right. So I see that the 22 divided by 11 comes first. So I'm going to do that first. 22 divided by 11 is 2. And times 30 minus 4, parentheses are still there. Okay, now I have multiplication, we'll do that. This is 60. Parentheses are still there until we have just one number. We can do our subtraction now, which is 56. Now we could lose our parentheses as the only thing left there is just a 56. Division comes before addition. And this would be 7. And finally, 7 plus 1 is 8. Okay, so that's our final answer there. Just make sure when you have your parentheses that when you look at just inside the parentheses, you then re-ask yourself about PEMDAS and the order it goes in. The other big thing is making sure that you're doing it from left to right if you have two of the same level at the same time. All right, so that's it for this video.